Let's talk about the graph of the derivative. So given the original functions, what would a graph of a derivative look like? And so this is a few steps to solve. Starting with the one on the left, f you're given. So it's a parabola. What would the derivative look like? Well, anywhere that you see it level off, anywhere you have a max or a min, the derivative is going to be 0. So at this point right here, we're going from decreasing to increasing. So at that point right there, that would translate down to here to be where the derivative is equal to 0. And then if it's decreasing, that's going to be below the x-axis for the derivative because it's negative derivatives. And if it's increasing, it's above the x-axis. Again, if the original graph, if f is decreasing, then that means the derivative is going to be below. If the original function is increasing, the derivative is going to be above, specifically the x-axis. So what do? Well, in this case, we can see that it's going from decreasing to increasing. So go from below to above. That's just one example. For g and g prime, so again, where do we have a max or a min? So we have a max here, which means that would be the derivative is 0, because to go from increasing to decreasing, to go from positive to negative, you had to cross 0 on the derivative. And then right here, it looks like we have a min, which would translate over here. So we're going from increasing, decreasing, increasing. So that's above, below, above, above, below, and above. This is the process to get the graph of the derivative. Now, I want to add a little bonus here. Eventually, you learn your derivative rules. And one of your derivative rules you're going to learn is, for any function x to the nth power, the derivative is going to be put the power in front and subtract 1 from the power. This is a rule you're going to eventually be using. That's the rule for x to a power, which means, for example, if a function was going to be, let's say, x to the 4th power, its derivative would be 4x to the 3rd power. You put the power in front, subtract 1 from the power. The reason I tell you this is because if you recognize what the graph is, for example, this graph right here is an x squared type graph, and the derivative of x squared would be 2x, which is linear in nature. Again, this is not exactly x squared, but it looks like an x to the 2nd power parabola, so I knew the derivative would just be a line. Over here, this looks like an x cubed graph, and the derivative of x cubed would be 3x squared, which looks like a parabola. And the only extra thing you would have to keep in mind is if it was negative, which means everything is flipped. But otherwise, here's how you work out the graph of the derivative. And again, that little extra bonus, if you know derivatives, it should give you a good idea of what to expect.